Okay, we have here today a good one from the UNSW Integration Bee 2024, problem 4. We have the integral from 0 to pi over 4, the sum from 0 to infinity of minus tan squared x to the k dx. Okay, initially when I first looked at this, I was really overcomplicating it, trying a lot of different things, trying u substitutions, until I noticed that what we have right here, this right here, is actually just a geometric series. So now we have our geometric series formula over here to the right, and you'll just notice, looking at our problem, the x value, the ratio in the geometric series, that's just going to be this value, the minus tan squared x. And before we can use this formula, we just need to confirm this part, that our ratio, this x value, that the absolute value of x needs to be less than 1. So what we want to look at, so tan at pi over 4 is going to be just 1. You put it in here, you're going to end up with minus 1. So at pi over 4, this is actually going to be 1, but just at 1 point. So that doesn't really matter in an integral because all the values below that, that's going to be less. When you go to 0, tan of 0 is just 0. So it turns out for this, all of our values are going to be between 0 and 1. So we're fine with this condition, and we can go ahead and use this formula. Now, rewriting the integral, we'll have our bounds the same, 0 to pi over 4. For this whole thing, we're going to rewrite it like this. This is going to become 1 over 1 minus this whole thing, which is going to be minus tan squared x. But then minus times minus gives me a plus here, and now we have 1 plus tan squared x. Well, for that, we have an identity, 1 plus tan squared x. I can rewrite that as secant squared of x. But then if I just take this and flip it and bring it into the numerator, when I rewrite this now as secant squared of the numerator, that's going to become just cosine squared of x. And then for this here, we can just use the power reduction on that. So I can rewrite this. What I'll do is I'll bring a 1/2 out front for this. And then this here is just going to become 1 plus cosine 2x. But now we're ready to integrate this thing. So just go ahead, we'll have our 1/2 out front. Integral of 1 is going to be just x. Integral here is going to be sine 2x all over 2. And we just need to evaluate from 0 to pi over 4. Well, at 0, everything becomes 0, so I just need to plug in this pi over 4 value. So what's going to happen, we're going to have half out front. This x here is going to become just pi over 4 plus sine 2 times pi over 4. We need sine of pi over 2 all over 2. But sine pi over 2, that's going to be just 1, so we just need to distribute in the 1/2 to finish this off. So for my final solution for this, we're going to get pi over 8 plus 1/4, and that's it. Okay, so there you have it. The whole key to it was just recognizing that what we have here, this sum, it's all just cosine squared x. And then after you rewrite it, it's actually a pretty easy integral. Okay, good one from UNSW 2024. Thanks everyone for watching. Have a good day.